Today we're on page 8 of the Chapter 12 Kinetics AP Chemistry packet, and we're going to be talking about reaction mechanisms. In order to understand what mechanisms are, we're going to tell a quick story. So let's picture you in the morning trying to get ready for school. So the beginning of your day consists of you in your bed sleeping, and all of a sudden your dad or your mom wakes you up and it's time to get ready for school. And lots of things happen along the way. You have to get up, you have to brush your teeth, get dressed, have some breakfast, and get your stuff. And you have to take a shower, of course, and then you go to school. So the beginning is you in your bed, and the final is you at school. Now, if we just look at these two as the reactants, you sleeping, and the product, you at school, there's a whole story along the way that was never told. Okay, we only see the beginning and the end. So in a chemical reaction, the reactants are what you have in the beginning. The products are what you have at the end. But there's a whole story in between that's not really told. Okay? So there are lots of steps that involve you getting to school. Okay? So you get out of bed. Let's say you take a shower. But unfortunately, there are several other people in your household and only one bathroom available. All right? So if you want to get ready for school, you're going to have to wait your turn to get in the shower. And then after your shower, you quickly get dressed, you quickly eat breakfast, you quickly brush your teeth, and you quickly zoom to school. All right? Now, no matter how quickly you can do all these things, the one thing that's going to really hold you up is getting into the bathroom because you're waiting your turn for all the other family members who need to use that one bathroom in your house. I'm sure a lot of you can identify with this story. So no matter how fast you do everything else, the bathroom is going to hold you up. So just like that process of many steps along the way, so in a chemical reaction between reactants and products, there are many steps, and in each of those steps, there's one step that's the slow step. So if we take a look now at these reactions right here, we see that we have several steps in this, what we call mechanism. A mechanism are the steps that are involved for a reaction to happen. So in this case, here's our reactant, C4H9Br, and that first is going to turn into this plus this. Then the C4H9 reacts with some water to make this thing, and then that thing reacts with more water to make this and this. If you were to add up all the left side and the right side, you could see that certain things are going to be able to cancel out on both sides. Like the C4H9 cancels out, this big OH2 thing cancels out, and now what you're left with is this, and these, and this, this, and this. So if you rewrote this, the overall reaction would be, this is not really responding very well, C4H9Br plus 2 waters yields the C4H9OH plus the H3O plus the Br minus. So this is the overall reaction. This is what happens overall. However, there were several things along the way that were produced which are called intermediates. So an intermediate is something that's formed in one step and then used up in another step. So intermediate and another intermediate is this right here. Okay, so we could list those intermediates on your paper. The intermediates here are C4H9, C4H9 positive, and C4H9OH2 positive. Those are intermediates. Okay, now very important to understand that the slow step in this mechanism was the first step. Okay, you would never know that unless you did an experiment. This is called the rate determining step, RDS, rate determining step. It's like the shower in the story. Okay, the shower held you up. This is the step that's going to hold up the whole chemical reaction. If you could speed up the slow step, you speed up the whole reaction. Lastly, catalyst. A catalyst is something that speeds up a chemical reaction by lowering the activation energy. So a catalyst is going to be present in the beginning and at the end, and it is unaffected overall. So you ended with a catalyst the same as you started, although inside the reaction it could be part of the structure of one of the intermediates like this, and then it could be in this intermediate here, and then get part of this intermediate, and then still in this, and then taken out one at the end, and it's unaffected. So the catalyst could be in any of these formulas at one point, but in the beginning it's by itself, and at the end it's by itself. So a catalyst can be canceled out, if you will, in this diagonal direction. However, an intermediate is canceled out in this diagonal direction. And lastly, if you wanted to sketch what we call a reaction coordinate, which was the same as those potential energy diagrams, with and without a catalyst, you saw ahead on the top of our sheet that there were 3 steps in this mechanism, and the first one was the slow step. So I'm going to draw that with the highest activation energy, and then I'm going to draw the other 2 with less activation. We don't know which one is stronger. I mean, you know, more or less, but either way, the first bump is the largest bump. Okay, so this is going to be without a catalyst in black, and then with the red, you would just have a lower activation energy for the first step, and it would not necessarily affect the other steps, and that would be with a catalyst. Okay, so the first activation energy is going to be from here to here, from the beginning to the top. That's activation energy 1 without a catalyst, and then with a catalyst is activation energy 1 in red, which would be smaller. But you're going to see that activation energies 2 and 3 are going to be still the same no matter what. So EA2 and EA3 are going to be the same. Okay? Please understand that the activation energy is from the beginning to the top for each step. Beginning to the top. Beginning to top is always activation energy.